Today is mid-November. I don't even know what date it is today. It's November 21st, really? That means 1 month and 4 days until Santa Claus. That's exciting. Did anyone ask for a PS5 for Christmas? Did you ask for one? I'm asking for one, but I don't think I'm going to get one. Um, I'm hoping Santa Claus finds it. I'm asking for a PS5 for Christmas. Here we go with the first four questions. They are true and false. So we have 0.9 squared is greater than 0.9. Now on your test, what you will have to do, of course, is simplify this. So 0.9, well, since 9 times 9 is 81, 0.9 times 0.9 means we have to move the decimal in our 81 twice, which would be 0.81. So really what this question is saying is 0.81 greater than 0.9? If you're not sure, because there's two decimal places, add a zero to make two decimal places. Think money. Is 81 cents greater than 90 cents? No, it's not. So therefore, your answer is flays. Flays. Question 2, a good estimation for 5.51 squared is 11. This, of course, if you knew why this question was written, is 5.51 squared does not equal 5.51 plus 5.51. 5.51 squared is approximately equal to 25 something ish. And actually it's more than that. That's probably around closer to probably 30. But we're saying 5 times 5 is 25, so we know it's greater than 25ish. So there would be my answer for this, is that do you know why 11 was the choice? Yes, because I'm saying, do you think 5.51 squared means 5.51 times 2? If you do, then you probably would have said true. But if you don't, if you know that it's multiplying it by itself, not adding by itself, then you would have got the right answer, right? So make sure you differentiate between does squaring mean multiplying by 2 or does squaring mean multiply a number by itself? So the answer is flays. Question 3. The perimeter of a square with an area of 28 meters square is approximately 21.2. So the first thing I would do, if this were my question, is I would do this. I would draw the square. And then I would say, okay, if that's the square, how do I get its side length? Danny, how do you get a side length of a square if you know its area? Square root. Now, since 28 is a non-perfect square, we know that 25 is a perfect square, and we know 36 is a perfect square. We could estimate just using that number line without a calculator that the side length is roughly, I would guess, 5.2 or 5.3. I'm going to guess 5.3. Since you could use a calculator, I didn't say you couldn't. You could take your 28, square root it, and it is 5.3. And how do you get the perimeter of a square if you know its side length? This is the gist of the entire, all the story problems we've done. Isaiah, how do we do that? If we know its side length, how do we get the perimeter? You can add it 4 times, 5.3 plus 5.3 plus 5.3 plus 5.3. You could do this, right? If you were in grade 4, that's what you would do. But if you're in grade 9, you realize that's the same thing as 4 multiplied by 5.3 because you learned way back in grade 4 that repeated addition can be expressed as multiplication. And therefore you would have 21.2. And therefore the answer is Traua. Traua. Right? Traua. True. Yeah. Question 4. 4 and 16/25 is a perfect square. Why would your teacher make this question? Because he is hoping, or she is hoping, perfect square, perfect square, perfect square. He's hoping somebody says this and then says true. That's what he's hoping will happen, right? But the answer is false. The answer is false. And you have to make a note here somewhere. You can't determine perfect squares. You don't have to write this one, but from mixed fractions. Mixed fractions. So this is one of the big sticking points for some people because they forget this rule. You can't determine perfect squares from mixed fractions, but you can if you change this into improper. 25 times 4 is 100 plus 16. If you change this to an improper fraction, now we know that it's not a perfect square. The denominator is, it's wonderful, it's 5. But there is no numerator that multiplies by itself to give you 116, and therefore it is not a perfect square. Even though 4 is, even though 16 is, even though 25 is, 4 and 16 25ths is not a perfect square. Question 5 asks us to estimate square roots using a number line. So actually, I think this is exactly the same one we just did. Square root of 25 is 5. Square root of 36 is 6. Square root of 34 would go right around here, which would therefore approximate it to be, I'm going to guess 5.8. Square root of 34 is 5.8 roughly. And you don't have to verify it with a calculator because I'm just asking for your, do you know what you're doing, right? Square root of 0.62. Well, we know that the square root of 0.49 is 0.7, and the square root of 0.64 is 0.8. We know that because of the board over here. And therefore, 0.62 would be around here, which would make the square root of 0.62 approximately, I don't know, 0.78. Does that seem about right? Everyone agree with that? Maybe? I probably did. And finally, 0.5. Now make a note here. Note, if you have 0.5, it's the same thing as the square root of 0.50, right? Pretty important thing to change it to, because without this, it's very difficult to make your posts, isn't it? But if you have that, then you know the square root of 0.49 is 0.7. Square root of 0.64 is 0.8, just like we had before. But this time, your number's right here, and therefore it's roughly 0.71 or maybe 0.72. Without this insignificant zero, this question was impossible to do. But if I ask you what's the square root of 0.50, then these were your posts. I would hazard to guess most of you had a hard time with that because you didn't add that insignificant zero to help you with your posts. Question 6 is, which of the following is a perfect square? Show how you know. Is 49 a perfect square? Yes or no, Ben? Yes. So we put a check mark here, preferably not with a highlighter. Check mark there. The reasoning is because 7 times 7 equals 49. Therefore, the square root of 49 is equal to 7. That's what I'd love you to put. That would be the perfect proof. Question B, is 1/4 a perfect square? The answer is yes, because 1/4 can be created with 1/2 times 1/2, and therefore the square root of 1/4 equals 1/2. Does that make sense? Is 0.9? The answer is no, it's not, even though 0.9 is, and here's why. 0.9 is equal to 9/10, and there is no fraction that multiplies by itself to get you 9/10. 9/100ths is, but 9/10 is not. And the last one, 1 and 7/9. What would your gut say looking at it? It would say not, right? But the answer is yes, it is. And here's why. 1 and 7/9, it's equal to 16/9, which is equal to 4/3 times 4/3. So therefore, the square root of 1 and 7/9 is equal to 4/3 or 1 and 1/3. Again, it's that whole, can you examine a mixed fraction to determine whether it's a perfect square? The answer is no. All mixed fractions should be examined as improper fractions. This is the key. If you didn't do this part here, you probably weren't able to get that part. Question 7 says the following numbers are perfect squares. So I've now said, you know what, listen, I'm not even going to ask you, are they perfect squares? I'm going to tell you they are. And all you have to do is express what the number is. So this is a decimal. And in order to find the square root of a decimal that is a perfect square, you should convert it into a fraction. So anytime you're given a decimal and you're asked to prove what its square root is, the easiest way to do it is say it's this. Therefore, the square root of 0.09 is equal to 3/10, because 3/10 and 3/10 are the same thing. Does that logic make sense? When you have a decimal, if you want to prove what its square root is, the easiest way to do that is change it to a fraction. This one is 4 thousandths, but we said we had to miss the 0, didn't we? We're supposed to put an extra 0 there, right? So that's 4 10,000ths, which as a fraction is this, which is 2 over 100 times 2 over 100. And therefore, the square root of 4 10,000ths is equal to 2 hundredths, a perfect square. Because 2 hundredths is the same thing as 2 hundredths. 1 and 44 hundredths. 1 and 44 hundredths. Uh-oh. That's a mixed fraction. Change it to a improper, which is 144 over 100, which therefore means it's 12 over 10 times 12 over 10 to get that number. And therefore, the square root of 1.44 is 1 and 2/10. All right? Does that make sense to everybody? 1.2 times 1.2. And the last one, 225 10,000ths. What times what is 225? 15 times 15. 100 times 100. So therefore, the square root of 0.0225 is going to be 15 hundredths. So therefore, the square root of 0.0225 is equal to 15 hundredths. Changing it from fraction back to a decimal. Question 8 says calculate the side length of each square listed. So since it's a square, I'm going to draw it. I'm going to put the perimeter equals 20. Now listen to me. If you have to use a formula, please, for the love of everything good, write your formula. The formula for the perimeter of a square is multiplying the side length by 4. The side length times 4, or as someone said earlier today, side plus side plus side plus side is the perimeter. So if you start with your perimeter formula, we know which of the two variables. Do we know the s or the p? We know the p, so we substitute it into our equation. Now this has now become an algebra equation with one variable. In fact, it's a grade 7 algebra question. How would I isolate for s? I would divide both sides by the coefficient. Correct? And I would end up with s equals 5. So therefore, what is the side length? The side length is 5 meters. Okay. How did I start it? Given the perimeter, I started with my perimeter formula. Substituted it, simplified it using basic algebra, and determined the side length has to be 5. In the second question, a different square. This time your area is 20 meters squared. Your formula for area is A equals S squared. Or, since I know my area, 20 equals S squared. Substitute what you know into your formula. At this point, I've almost isolated my variable. What do I have to do, Daniel, to both sides? Square root both sides. The square root of S squared is just S, because S times S is S squared. And the square root of 20, using my super duper methods of estimation, square root of 20 is probably right around yonder, just before the midway point. So I'm going to guess 4.5 is not a terrible answer, is it? Right? 4.45 is probably what it really is, but 4.5 is the side length. So the side length is approximately, if you had 4.5, good. If you had 4.4, fine. If you had 4.45, excellent. But all of that work is required to show you know what the side length is, right? I don't want you to just do the work in your head. Show me all that work. Now we get into the story problems, which, if I remember correctly, is Madeline Cornish's favorite types of questions. She loves them. She's like, Mr. McDowell, could I just have more story problems? I just love them so much. Said Madeline, never. It does say Adriana, though. Weird that that's the name chosen. I have no idea where that came from. Did I spell it right? Didn't spell it right. Oops. Needs to replace a strip of laminate that is glued to the vertical faces of a square tabletop. The most difficult part is just understanding what the heck that sentence means, right? And what that sentence means, if this picture here is a tabletop, this is the laminate trim that has to go around the outside of the table, just like that. So it's this little strip of wood right here, that little strip. You need to put those, it's almost like, you can think of it as like hard tape. The tabletop has an area of 2.25 meters squared. What's the length of laminate that she needs? So really, first thing you need to do is find out, well, what is the side length? Side length will be the area equals side squared. 2.25 equals side squared. Square root both sides. You then know that the edge length is 1.5 meters. Are we done yet? No, because actually the amount of laminate she needs to go around the outside of the square is actually known mathematically as what word? The perimeter. So then we then take that and say the perimeter is equal to 4 sides, or the perimeter, the amount of laminate she needs, the perimeter, will be 4 1.5 lengths, which means the perimeter will be 6 meters of laminate she needs. 1.53, 4.56. 6 meters of laminate, and therefore, because it's a story problem, put your there. Therefore, the amount of laminate needed is 6 meters. Any questions with the expectations on that story problem? Pretty straightforward. Not hard. Not a hard question. Make sure for both of them, though, you show your formulas, you show your substitutions, and you solve them. Question 10 is your paint, which is apropos since yesterday we painted the food slab. This is a label on a 1 liter can of paint states that the paint will cover an area of 24 square meters. What is the side length of the largest square that the paint will cover? So if I draw my square, simple, simple, simple. Area equals 24 square meters. Area equals side squared. 24 equals side squared. Square root both sides. Without even doing the number line, what's the square root of 24? Roughly, in your head. If the square root of 25 is 5, 4.9 is a perfect guess, or 4.8. Either one without a calculator is all you need to do. So therefore, the side length is approximately equals with a dot above it, 4.9 meters. Right? Roughly. If you needed a gallon of the same paint, or if you used a gallon, what is the approximate side length? So what this means is you don't have 3.79 side lengths, is really the question is. If you had 3.9 liters, it will do 3.9 times this much area, right? So we have to multiply the area it will do by 3.79. So first step 1 is 3.79 liters multiplied what 1 liter will do equals, grab my calculator here, 3.79 multiplied by 24 equals 90.96. Therefore, the square in question can have an area of 90.96. Are we done? No, that's just the size wall you can do. The question says, What is the side length of that larger wall? Which is not the same question. So therefore, the area equals side squared again. Area equals, 90.96 equals side squared. Since I do know the square root of 81 to be 9 and the square root of 100 to be 10, and I'm pretty freaking sure that 90.96 is pretty close to the exact middle of that number line, right? I could probably safely say that if I square root both sides, the side length is approximately equal to 9.5 meters. Question 11 says, some parks contain fenced gardens. Of course they do. Suppose that it costs $60 to build each meter of fence, including materials and labor, taxes included. Approximately how much does it cost to enclose a square with an area of 140 square meters? So I'm starting to become redundant here, but this is pretty simple. Area equals side squared. 140 equals side squared. Square root both sides. What's the square root of 144? 12. So you could draw your number line again. Square root of 144 is 12. Square root of 121 is 11. I'm guessing the side length would be what? Would we all agree 11.8 is not unreasonable? 11.8 sound reasonable to everybody? I don't know what it is. But since I'm not using a calculator, 11.8 sounds very reasonable. So if 11.8 is the side length of that fenced area, do I know enough information to determine how much it's going to cost to build a fence around it? No. What is the missing piece of information for that fence? The perimeter. So then I take my formula, P equals 4S. I then say the perimeter, or the distance around this garden, will be 4 multiplied by 11.8. That will be how much fence I need to go around the entire perimeter. Or 4 times 11.8 equals 47.2 meters. Am I done yet? I'm not even done yet, because that's just how many meters it is. And if every meter of fence costs $60 to build, and I have to build a perimeter of 47.2 meters, there's an assumption we're making here, by the way, that you can buy a fraction of a fence, right? So we'll make the assumption you can. Your final step will be taking 47.2, step 3. I'm going to put step 3 over step 1, step 2, step 3, is to take your perimeter, your distance. You have 47.2 meters multiplied by the $60 per meter, and therefore, ergo, 47.2 multiplied by the 60 equals $2,832. Therefore, it will cost $2,832 to build the fence. Now, I really like B, because B says if there are two squares that are attached to each other, and this one has a 70 square meters, and this has 70 square meters, what's the area of this rectangle? It's still 140. It's the same amount of area as this square, but we put two 70-meter squares together to give that 140. So this, if I traced it with a yellow highlighter, you would agree that that yellow rectangle has an area of 140 square meters. The same as this yellow square, even though they're different shapes, a rectangle and a square. No, but it's not. So here's what we need to determine. Do we know how long that is? We don't, do we? Can we figure it out? Yes, we can. Because we can figure out this distance here, can't we? And that distance will be the square root of 70. Which if I use my number line, I could figure it out, but I'm going to guess it's like 8.4. 8.4. So what this tells us is that this distance of a rectangle is 8.4. All right, now here's the question. How many 8.4s make up the perimeter of that rectangular field? How many raise your hand if you got the answer. Listen carefully. How many 8.4s make up the perimeter? Raise your hand if you know the answer. If I only got 2 hands, I know that nobody's listening. Make up the perimeter of that field. How many 8.4s? Oh, I think I didn't record that, did I? Shoot, where did I stop recording? Oh my God, did I really? Hmm. Did I really? Oh God. All right. Hopefully you all understood this, and hopefully I recorded the video. I'll go back in time real quick just to recap. Here we go. Real time recap. I know it sucks. Oh, sugar cubes. I even went back a page. Oh no, I'm down here. Oh my God, it's just so. When I put the two squares together, I determined that each of them was 8.4. The perimeter of that would be made up of 6 side lengths, not 4, because it's a rectangle. 6 8.4s give us a perimeter of 50.4. And since the square's area was 47.2 and the rectangle's area was 50.4, therefore it's more expensive to fence 140 square meters of a rectangle field than a square field. Last question. My home office is 5 meters long by 2.2 meters wide. Therefore, I'm hoping you realize that's a rectangle, right? So you took your room, you made your rectangle. It looks like this. This is my room. Those are the same lengths. Those are the same lengths. I have a square rug in this room, square, that takes up a quarter of the total area. Okay. What is the side length of my rug? Well, there's a lot of things to unpack here, isn't there? What's the first step? What do you think the first step is? Ben, what would you do first? Yeah, so if I find the area of the whole room, so step 1 is the room. So we have an area. So area will be length times width because it's not a square, it's a rectangle, or 5 times 2.2, which means the area of this room is 11 square meters. That's the first step. Okay, so my office room has an area of 11 square meters. That's not the rug, that's the room. Okay, step 2 is determining if this rug takes up a quarter of this area, then we want to figure out what is a quarter of 11. Agreed? Because if the whole room's 11, I want to find a quarter of that. Since it doesn't have to be fractions, I'm going to change it to decimals. Would everyone agree that if I want to determine how much area the rug is, I'm going to multiply the area of the room by decimal 2.5. A quarter of 11. A quarter of 11. A quarter of 11. So that rug, if I take it, a quarter of 11, I could probably do that in my head because what's half? It's 5.5. Half of that would be 2.75, which is 2.75. So therefore, the area of this rug, if I take my eraser, is 2.75 square meters. You with me so far? Is that right? Did I do everything right so far? Okay. Now, the question says, this is the one that we're answering, what is the approximate side length of the rug? So I now know what the area of the rug is. In order to get its side length, area equals side squared. 2.75 equals side squared. This is probably the hardest one for your number line. Watch this. 2.75 is going to be between, oh, we don't even have that hard, do we? How about we just square root 2.75? How about we just take 2.75 on our calculator and say, what is the square root of that? Somebody help me. And the answer is 1.65. 1.66. How did I not get that up there? Oh, it's right here. Sorry, I could do this. See, even I get confused. Oh no, I got the wrong number lines. Hang on. Square root of 2.56 is 1.6. The square root of 2.89 1.7. That's the two you needed to use. I'd say it's right around here, which would be 1.6. What did you say it was? 6.7? What did we say it was? I can't remember what it was. 1.66. Yeah, 1.66. So therefore, the edge of this rug is approximately 1.6 or 1.7 meters long, approximately equal to. Does that make sense to everybody? In just a second. I'll go back in time and show you this again one more time. One more time, going back and 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 back. So step one, since I knew the rug occupied a quarter of the area of the room, but I didn't know the area of the room, I first determined the area of the room to be 11. Since the area of the rug took up a quarter of that, I figured out what is a quarter of 11, changed it into a multiplication statement, and figured out that it was 2.75 square meters. Once I had that, square root of 2.75 can be determined on a number line by using the, oh, not those ones, these ones, as your benchmarks. And therefore, I figured out, just not without using a calculator, that the approximate side length of that rug is like 1.66 or 1.67, 1.7, whatever. And that's how we answered.